Welcome to this quick start guide for Cancha Geometallurgy. In this guide we're going to be talking about how to use the targets feature in Cancha to determine the best models for your geometallurgical model. For this we're going to be using the Catalina gold test results data set. There'll be links in the show notes below as to how to get this data set. Basically imported 4 tables. Those 4 tables, let's go to Excel and just see what's inside there. We've got basically we've got the collars table, just to explain where the drill holes are. Origins table, which explains for each sample which drill hole it was taken from, and the from and to interval that was the sample taken from. Characteristics table, in this case we've got mine zone, hypogene, supergene, oxide, whatnot, and some head assays, different chemical assays for each sample. A results table, so for each sample we've got the gold recovery and the cyanide consumption. Of course, when we talk about the sample IDs, we talk about the sample ID and phases. It's a good idea to always put which phase test work you have and the full sample ID in order to keep good traceability of where your samples are from. So this Excel was imported back into Cancha, and here are the tables here. You can see the same data, and we can just have a quick look in 3D and see that this is what the data looks like. We've basically got look, we're at the sulfur grade here. You can see deeper down we've got higher sulfur grades. Gold grade seems to be a bit higher up. There seems to be higher gold grade. And we can look, for example, at the gold recoveries. And here we can see that the better gold recoveries are up near the surface. So this is interesting, but nothing we can really build a model around yet. So what do we typically do? We might go to analysis, and the old way of doing this sort of work, you might say, okay, well, show me gold recovery. Let's autocorrelate that, and we can see very quickly that we've got a negative correlation with sulfur, a slightly positive correlation with the gold grade, a slightly negative correlation with the copper grade. Nothing that's really blowing our minds here as metallurgists. This is quite expected. And a whole bunch of these other elements, aluminum and potassium and whatnot, which really don't have any correlation at all. So this is interesting. Again, nothing we can build a model around yet. So let's have another look at this gold recovery, and let's plot it. We saw that sulfur was interesting. We'll just grab the sulfur grade here from the characteristics table, and sure enough, look, there's a good relationship. You got higher sulfur grade, lower recovery. Lower sulfur grade, higher recovery. You can see that we've got a lot of points here, and then maybe there's something more we can do here. We can put the zone on here and say, okay, this is interesting. So here we're not seeing so much as a trend as domains. We can see that these zones are really quite separated for these away from these. So maybe just a grade up regression might not be the best way to go. Maybe we might have to look at domaining. Well, to do domaining, you quite often look at the box plot. So let's try that. So we put the gold recovery and say, okay, let's have a look again at by zone. And sure enough, we can see some separation. That's what we're expecting from that XY graph. We can see that the hypogene's got lousy recovery, and the oxides, gossan, leach cap, they all have higher recovery. So again, nothing surprising here, but is this the best model? Especially in the supergene, seems to be quite a big range of gold recoveries here. Maybe we can do better. We also thought that sulfur was an interesting one. So let's put sulfur in here. We can see, yeah, okay, low recovery with high sulfur. So when we've got over 4.5% sulfur, we can see that we've got low gold recovery. But high recoveries here are wide range with the low sulfur. So it's not very precise just using this. So this is the way that we, for years have gone about trying to find what's the best geometallurgical model. Just trial and error, trying to plug in as much as we can, the different hypotheses, drawing the graphs and seeing if anything falls out. And certainly the analysis module in Cancha certainly helps with that. But the targets module does it all for us. So we'll just click on the targets here and click on the plus sign, and this will create a new target. And we'll identify that a target we want to use is the gold recovery. So just drag it from the features list up into the feature target. Automatically, it's loaded up all the features from the characteristics table that had data. These features here are the ones that have data sets that correspond to the gold recovery. We can see here that there was another feature in the data set, which is the cyano consumption, but it's ignored because it's in the results table. It's very rare that you can use something from the results table to predict another result. So that's why that one's ignored. If we wanted to include it, we could just pull it over here, or to remove it again, just double click. So we can see here we've got things like the zones, which are categorical information, and all of these grades here are numerical information. They're just all together in the features that are going to be considered. These are the things that we want to consider in order to predict the gold recovery. Hit run. Cancha runs all the regressions against everything, and bang, it's found that for the 100 samples, it's found that we've got a global model, or we can have a model by sulfur or by zone, which is kind of ties into what we were expecting from our knowledge of the domain. So let's look at the global model first. So this is basically saying all 100 samples, one single model, the gold recovery is equal to minus 5.5 times the sulfur plus 3 times the gold grade plus 78. Okay, it's got an R squared of 0.861 or an adjusted R squared of 0.858, which is really, a very good model. For it to be valid, we'd hope that the sulfur and the gold separately would have good correlations with the same target. Like you can see that, yeah, the sulfur is pretty good, but the gold, there's something going on here. There seems to be two areas. You got the domain here and the domain here. There seems to be something more that's happening. We can also look at the residuals analysis. We can see that, okay, the residuals are normally distributed, so that's a good indication. They don't seem to be heavily weighted, against the predicted values. So it seems to be a fairly good model in all parts of the curve. Okay, so that's not bad. That might be a candidate model, but let's see what would happen if we would look at the sulfur one. So first of all, by domaining by sulfur, low, medium, high grade sulfur, we can end up with this separation. So we can say, okay, the low and the medium ones seem to have quite a lot of data and only 16 values in the high. And it's giving us formulas for each of these and a constant value for the high one. So let's have a little look. We can see here we've got a formula. The gold recovery is equal to 76 plus 3.9 times the gold grade. That's interesting. But it doesn't seem to be a major improvement over what we've seen in the last model, or the global model. And look at the median one. Here we can see very clearly that it's, what's this, 88 minus 9.7 times the sulfur grade. So, again, this is a pretty good relationship here, and this is a pretty good model. It doesn't seem to be a marked improvement over just the global model by itself. And when it comes to the high sulfur material, it just says, look, you've got, something like 51.2% gold recovery, plus or minus a couple. Okay, so it's not saying that, you know, it didn't find any regressions, didn't find any formulae. It's just saying that it's a constant value. It is the best one. You can see here it's given us two. We can use either this one or this one. The one with a star on it is the one that it's recommending. It's recommending using the mean value of 51.2. But we could also have a look here and say, okay, the median value is 51.7. They're both very close to each other. You can see the difference here between the mean and the median on the box plot. Yeah, and you know, either one of those would be fine to describe that domain, but there's only 16 out of 100 samples in that domain. Let's see what would happen if we look at zones. Okay, we've seen this before, that they're all looking pretty good, except for the supergene. The supergene seems to have a pretty wide band, a lot of variability in the supergene. Let's see what it found in there. So it found a formula. It found that, you know, 90% minus 10.45 times the sulfur grade. Oh, okay, so this is good because, you know, even though it had a wide band of values, you know, from 50 up to 70% gold recovery, it found that by including the sulfur in there, we can get a really good 0.9%, 0.9 R squared. So that's a really good model. Yeah, Negosson, you can see that in this case, Negosson, 72% plus 4.7 times the gold grade. In the oxide, 97 minus 25 times the sulfur grade. Well, this is interesting. The oxide and the supergene have both got sulfur and a constant, but they've got different constants in there. So that's something we could maybe have a look at later and see whether the supergene and the oxides could be combined because they've got a similar function. And the hypogene, again, you know, so this was the high sulfur material pretty much, wasn't it? And again, it's seen exactly the same thing again, no relationship. 17 values in the hypogene, 51.2% plus and minus a few percent. So it looks like the hypogene doesn't have any regression. And the leach cap, wow, bang. So this is 4.6 times the gold grade plus 74. That seems familiar, doesn't it? Let's look at the oxide, what is it? No, the Negosson, sorry. So the Negosson was 72 plus 4.7 times the gold, and the leach was 74 plus 4.6. So it seems like those two could be joined together again. So we were wondering, you know, maybe we've got a couple of domains here. Maybe we've got the leached and the Negosson, the oxide and the supergene, and the hypogene. So 3 domains, and that would give us a pretty good model. Or the alternative is we could just use the global model, you know, using a single formula that would describe everything, which isn't bad. I mean, you know, it's worked out pretty well. You know, maybe a bit more errors here and you know, a little bit off on some of the extreme values. Not perfect for anything, but pretty good for everything. So anyway, you know, the rest of it's hard work. You know, you'd have to dig into, you know, we can use the features editor to create new features and classify the features into different summarized domains. But, you know, very quickly, what Cancha did was able to, you know, discard a whole bunch of these other elements and be able to check all the different domains, all the different levels, all the different ones, and give us some models here that worked out pretty well. Let's just very quickly go in and do another one. So let's just grab this cyanide consumption. Same thing again, let's just let it rip. So it's just checking all these against everything here, and again it's found that sulfur is an important one in the zone. So let's have a look at the sulfur. You know, again, high cyanide consumption with high sulfur. Well, that makes sense. We didn't look at the global one. Okay, So global one, look at this. Okay, so 2.6 kilos a ton plus 1.3 times the sulfur grade plus 2.6 times the copper grade, and that's a pretty good model too, the global model here. A little bit of a bias here, so we're predicting 3 kilos a ton as a minimum, whereas the actual got down to closer to 1. So maybe a bit of improvement possible here. If we go to the zones and have a look and say, okay, what's hypogene's a bit weird, why is that? Was only 17 values. We've got 2 models here. We've got one which is just a 1.56 times the sulfur plus 2, and we've got one which involves aluminium. So this is a good example of what you have to be a bit careful for. This aluminium one, okay, let's have a little look at the statistics here. At the statistics model here, and we can see that aluminium's got a p-value of just over 0.05, so which probably means that we shouldn't probably be using it. Okay, it's just not that good a relationship for the small amount of data that we've got. So Cancha's shown it to us because it thought it was interesting, but maybe not the best way to go. The other model just, pretty much the same thing, sulfur and a constant, and taking out the aluminum. I think this one. So let's make this one recommended. We don't want to use one that has a spurious p-value. And here we can see this has got a much better p-value. You can see it's very, it's got a good influence. Sulfur's got a good influence over the cyanide consumption. So let's use that one. So you just right click on there and say make recommended. So we've got that. That's the recommended one. And so now when we go back up here, we've replaced that one in here. And then, so we've got, basically we've got a model here for the cyanide, and we've got another model for the gold recovery. Okay. And we can continue to add more and more features if we wanted to. If we wanted to try out different hypotheses, we could force it by, just taking out some of these other features that it's getting, and just leaving ones that we want to test. But basically, that's it. You're able to get these, get through the chaff real quick, and you can either come up with a global formulae that works for all the samples, or else, it's going to recommend domaining systems. And then inside each domaining system, give you, either constant values or possibly give you formula if any are statistically relevant. But of course, when you're using this, it's an automated system, garbage in, garbage out. You have to be very, very careful.